Hi there. This is gonna be the third example of using the Cholesky method in order to solve system linear equation. So I basically made the very first video in which I explained everything with step by step, and a second video in which I explained everything, but not going through each and every step. And this is gonna be the third one. So I'm gonna speed it up a little bit here. All right, so let's start with the matrix. So 3, 1, -1, 1, 1, -1, -1, -1, 2. It's gonna be our matrix. Our matrix A. Then we're gonna have our vector x is a 3 by 3 matrix. Therefore, we are in a three-dimensional space. Therefore, our vector x is with component x, y, and z. It's going to be equal to our coefficients 2, 0, 0. And therefore, this gives us our system of linear equation, which is 3x plus y minus z equal to 2x plus y minus z equal to 0, and negative x minus y plus 2z equal to 0. Alright, so this is basically our system of linear equation. So let's crack on and start with the Cholesky method. But before we do that, please note that this is a matrix and we have to check whether A is an SPD or not, so a symmetric positive definitive matrix or not. So if it is, we can go on and do the Cholesky decomposition. If it's not, then we're not gonna proceed and do the decomposition. All right, so basically, in the other matrices, it was actually pretty clear. It was actually pretty straightforward that it was a symmetric positive definite matrix. I'm sorry. In this case, it's not. It's not immediate. Like it's not. You may not see it at the first glance. It is indeed symmetric because you have 1, 1, -1, -1, -1, -1. So it's actually symmetric, but is it positive definite? Well, a way we can find out is to basically take the determinant of such a matrix. So 3, 1, -1, 1, 1, -1, -1, -1, 2. So if you remember, we can actually use Sarus. I made a video about the Sarus rule. So basically, the first diagonal plus B, F, G plus C, D, H minus A, F, H minus B, D, I minus the other diagonal. I'm really gonna speed it up here because otherwise it's gonna be 1 hour long video and nobody wants that. Anyway, this is out. You can actually find a video in which I basically explain how to go through the Saros method of finding the determinant. All right, so first diagonal, so 3, 1, 1, 1, -1, 1 plus -1 times 1 times -1 times 1 times -1 minus 3 times -1 times -1 minus 1 times 1 times 2 minus -1 times 1 times -1, which is the other diagonal. Okay, so let's compute this. This is 6 plus 1 plus 1 minus 3 minus 2 minus 1, which is 6 minus 4, which is 2. So the determinant is actually positive, and therefore we're good because the determinant is positive. So we can apply the Cholesky decomposition. So basically I'm going to rewrite the matrix. So 3, 1, -1, 1, 1, -1, -1, -1, 2. This is my matrix. The reason why I'm rewriting it because I'm gonna call those coefficients A11, A12, A13, A21, A22, A23, A31, A32, A33, right? So those are going to be those. And what we want to find is that we basically want to find the lower triangular matrix and its transpose, because L transpose is going to be equal to A. So our lower triangular matrix is going to be L11, 0, 0, L21, L22, 0, L31, L32, L33 times the transpose. The transpose is actually L11, L21, L31, 0, L22, L32, 0, 0, L33. And doing L times L transpose is actually going to give us L11, L11, L21, whoops, there we go, L11, L31, L21, L11, L21 squared plus L22 squared, L21, L31 plus L22, L32, L31, L11, L31, L21 plus L32, L22, and then L31 squared plus L32 squared plus L33 squared. There we go. So this is going to be our matrix. So now what we want to find is the elements in order to have our lower triangular matrix. Therefore, we're looking for L11, which is actually going to be given by the square root of A11. And therefore, A11, 3. Therefore, square root of 3, which is just the square root of 3. I cannot simplify any further. Okay, so L21 is actually going to be A21 over L11. And therefore, in this case, it's going to be 1 over square root of 3. Which I can rationalize actually. So 1 over square root of 3 times square root of 3 over square root of 3 is going to give me the square root of 3 over 3, which is fine. So now we're looking for L22, which is square root and square root of A22 minus L21 squared, which is going to be 1 minus the square root of 3 over 2 squared. It's going to give us, well, it's going to give us 1 minus 3 over 9. 3 over, I'm sorry, 3 over, yeah, I'm sorry, this was square root of 3 over 3, not over 2. So square root of 3 over 3, so 3 over 9. So it is 1 and this is 3. And it's going to be 1 minus 1 over 3. So it's going to be 3 minus 1 over 3. So the square root of 2 over 3, which is square root of 2 over the square root of 3. I can actually rationalize it. So times square root of 3 over the square root of 3. And it is actually going to give me the square root of 6 over 3. Okay. So now we're heading for L31. And L31 is just A31 over L11. So in this case is actually -1 over square root of 3. Okay, so this is actually -1 over the square root of 3. I can rationalize it like so. So times square root of 3 over square root of 3, and this gives me the square root of 3 over 3. And now I want to find L32. So I'm just trying to find L32. There we go. So basically L32 is actually going to be A32 minus L31 times L21 over L22, which is okay. Whoops. There we go. So it's actually -1 minus negative square root of 3 over 3 times square root of 3 over 3, everything over the square root of 2 over 3. So this is actually going to give me -1 minus negative 3 over 9, which simplifies as 1 over 3. Everything over the square root of 2 over 3. So we basically have -1 plus 1/3 over the square root of 2 over 3. And this actually gives me -3 plus 1 over 3, everything over the square root of 2 over 3, and this gives me -2 over 3 over the square root of 2 over 3, which gives me 2 over 3 over the square root of 2 over 3. And now I can actually use the property that B over C over A is actually B over C times A. So if I do that, I basically get 2 over 3 times the square root of 2 over 3. And now I can say that actually the square root of A over B is actually the square root of A over the square root of B. And therefore, I get -2 over 3 times the square root of 2 over the square root of 3. So this actually gives me -2 over 3 times the square root of 2 over the square root of 3. Now I can use the property, I can actually use the property that the root n of A is actually A to the 1 over n. This is just calculus, you know, that's like plain calculus basis. So 2 over 3 times square root of 2 over 3 to the 1 over 2, which actually gives me, I can use the property once again, that x to the A over x to the B is equal to x to the A minus B. And so I get -2 over 3 to the 1 over 2 plus 1 times square root of 2, which gives me -2 to to the 3 over 3 to the negative 1 plus 2 over 2 times square root of 2. And so I get negative 2 so negative 2 over 3 to the 1 over 2 times the square root of 2 equal to, and now I can use once again the property of a to the 1 over n, which is actually equal to the root n of a. And so I basically get negative 2 square root of 3 times square root of 2. So this is actually negative negative 2 over square root of 6, which actually gives me, well, I can rationalize it. 2 over square root of 6 times square root of 6 over square root of 6, which actually gives me my negative 2 times square root of 6 over 6. I can simplify it, so I get 3, 1. And therefore, I get negative square root of 6 over 3 for L3, 1. Okay, and now we only have to find L33, which is the very last one. Okay, so L33 is actually A33 minus L31 square minus L32 square, which is actually gonna give me, well, let me see, okay, come on. Okay, so this is actually gonna give me 2 minus square root of 3 over 3 raised to the power of 2 minus negative square root of 6 over 3 raised to the power of 2, everything under the root. So this becomes 2 minus 3 over 9, which simplifies as 1 over 3, minus 6 over 9, which simplifies as 2 over 3, which is actually gonna give me 2 minus 1 over 3 minus 2 over 3. So I get 6 minus 1 minus 2, everything over 3, and therefore I get 3 over 3, which actually gives me 1, so the square root of 1, which is 1. Okay, we're getting there. So basically we have found L and L transpose. So basically L is actually going to be the matrix given by L11, if you recall, 0, 0, L21, L22, 0, L31, L32, L33, and therefore okay, and therefore I basically got square root of 3, 0, 0, square root of 3 over 3, square root of 6 over 3, 0, negative square root of 3 over 3, negative square root of 6 over 3, 1. And L transpose instead is actually gonna be, well, let me see, L transpose. Okay. Okay, so basically get, well, L11 L21, L31, 0, L22, L32, and I have 0, 0, L33. So I get square root of 3, square root of 3 over 3, negative square root of 3 over 3, 0, square root of 6 over 3, negative square root of 6 over 3, and 0, 0, 1. There we go. So this is L transpose. Now that we have L transpose, we can, well, we actually know that A times X, which is the vector we have to find, equal to C. And we also have that L and transpose equal to A. And therefore, L transpose X is equal to C. And therefore, if this is true, what we're going to do here right now is to basically take, as I said in the other videos, take a new, well, take the L, the lower triangular matrix, take a new vector y with the component I, j, and k, and set it equal to c. And then once we found it, we're gonna use L transpose x. So we're gonna find x, y, and z, our value that are gonna give us the solution, and we put it equal to y, the vector y, so the one with the component we're gonna find in the very first step. So let's do this. We have L, the lower triangular matrix, which is L, which is square root of 3, 0, 0, square root of 3 over 3, square root of 6 over 3, 0, negative square root of 3 over 3, negative square root of 6 over 3, and 1. Okay, so this is actually the lower triangular matrix. So times y with the component I, j, and k that we have to find, and we set it equal to c. So the c here, that was 2, 0, 0. So basically have 2, 0, 0. There we go. It's going to give us a linear system equation. So we basically have square root of 3i equal to 2, square root of 3 over over 3 I plus square root of 6 over 3j equal to 0, and then we have negative square root of 3 over 3i minus square root of 6 over 3 j plus k equal to 0. And then we have to actually solve it. So this is actually going to give us, well, I is going to be equal to 2 over square root of 3. And then we have square root of 3 over 3 times 2 over the square root of 3. So we are actually lucky, and those two guys simplify, plus square root of 6 over 3, j equal to 0. And then we have negative square root of 3 over 3 times 2 over square root of 3. Once again, we're lucky, those two guys simplify. And we have minus square root of 6 over 3 j plus k equal to 0. So I is still going to be equal to 2 over square root of 3, 2 over 3 plus square root of 6 over 3j is going to be equal to 0. And then we have a negative 2 over 3 minus square root of 6 over 3j plus k equal to 0. And this is actually going to give us I equal to well, 2 over square root of 3 times square root of 3 over square root of 3. We have square root of 6 over 3j equal to negative 2 over 3. And then we have k equal to 2 over 3 plus square root of 6 over 3j. And then we go on, and we got, what do we got? Well, we get I still equal to 2 times square root of 3 over 3. J equal to negative 2 over 3 times 3 over square root of 6. So those two guys simplify. And we have k equal to 2 over 3 plus square root of 6 over 3j. So we have I equal to 2 times square root of 3 over 3j equal to negative 3 over square root of 6. K equal to 2 over 3 plus square root of 6 over 3 times negative 2 over square root of 6. Those two guys simplify once again, and therefore we have I equal to 2 times square root of 3 over 3. J equal to negative 2 over square root of 6 times, I'm rationalizing, square root of 6 over 6. K equal to 2 over 3 minus 2 over 3, so those two guys cancel out. Okay, so we basically have, we're getting there, 2 times square root of 3 over 3, j equal to negative 2 times square root of 6 over 6, so those two guys simplify, I get 1, and here I get 3, and k is equal to 0. And then we have I equal to 2 times square root of 3 over 3, j equal to negative square root of 6 over 3, and k equal to 0. So that's fine. Now we have found I, j, and k. This is not my solution, so our solution. Now that we have found I, j, and k, we're gonna use the L transpose matrix and find x, y, and z by putting them equal to I, j, and k that we had just found. So let's just do this. So now we're going to find, we're going to do L transpose x equal to y. So L transpose, we're just going to get it back. It was this one, this matrix 1, this matrix. So it was actually square root of 3, square root of 3 over 3, negative square root of 3 over 3, 0, square root of 6 over 3, 6 is 6, negative square root of 6 over 3, and then we have 0, 0, 1. So these are lower triangular matrix transposed. Okay, so times x, y, and z that we have to find equal to I, j, and k, so those three guys. So 2 times square root of 3 over 3, negative square root of 6 over 3, and 0. And so this is actually going to give us our last system of linear equation, which is square root of 3x plus square root of 3 over 3y minus square root of 3 over 3z equal to 2 times the square root of 3 over 3. Then we have square root of 6 over 3y minus square root of 6 over 3z equal to negative square root of 6 over 3, and then we have z equal to 0. There we go. So let's try to solve this. Hopefully it won't take too long. So square root of 3x plus square root of 3 over 3y minus 0 equal to, equal to 2 times square root of 3 over 3. So then we have square root of 6 over 3y minus 0 equal to negative square root of 6 over 3. And then we still have z equal to 0 hanging along for the ride. So we get square root of 3x equal to 2 times square root of 3 over 3 minus square root of 3 over 3y, y equal to negative square root of 6 over 3 times 3 over square root of 6, and we're very lucky because those guys all cancel out and z equal to 0. So let's go on, and we basically get square root of 3x equal to 2 times square root of 3 over 3 minus square root of 3 over 3y, y equal to negative 1, and z equal to 0. And then we have square root of 3x equal to 2 times square. Oh, I'm writing. Am I writing? No, I'm not writing. Oh, whoops. My bad. So equal to 2 times square root of 3 over 3 minus square root of 3 over 3 times negative 1. And then we still have y equal to negative 1 and z equal to 0, both hanging along for the right, which is anyway close to the end. So square root of 3x equal to 2 times square root of 3 over 3 plus square root of 3 over 3, y equal to negative 1, z equal to 0. And so we have square root of 3x equal to 2 times square root of 3 plus square root of 3 over 3, y equal to negative 1, z equal to 0. And so we get square root of 3x equal to 3 times square root of 3 over 3. Those two guys simplify, 1, 1, and y still equal to 1, and z still equal to 0. And so we get square root of 3x equal to square root of 3, y equal to negative 1, z equal to 0, and so we get x equal to square root of 3 over square root of 3. Those two guys cancel out, y equal to negative 1, z equal to 0, and therefore our solution is x equal to 1, y equal to negative 1, and z equal to 0. There we go. But let's check it. So our system of linear equation, our initial system of linear equation was where the fuck is it? Oh, there we go. It was this one. So we're now gonna try the values that we got. So 1, negative 1, and 0. So let's try with the first equation. We got 3 times 1 minus 1 minus 0 equal to 2, and therefore we have 3 minus 1 equal to 2, and it's absolutely right that 2 is equal to 2, so we are happy. Now let's try with the second equation by substituting those three guys. So we have 1 minus 1 minus 0 equal to 0. So we had 0 minus 0 equal to 0, and it is absolutely right that 0 is equal to 0. So we are happy. Now we're crossing our fingers for the third equation. By substituting those three guys in the third equation, we got negative 1 minus negative 1 plus 2 times 0 equal to 0. So we basically got negative 1 plus 1 plus 0 equal to 0. Negative 1 plus 1 cancel out, and so 0 equal to 0. So it's verified. Our solution x equal to 1, y equal to negative 1, z equal to 0 is verified, and therefore our system of linear equation is solved using the Cholesky decomposition. So let's do a very quick recap, just to make sure. Matrix A, vector x equal to c, it gives us a system of linear equation. So basically, we start with the matrix is 3 by 3. We check that is an SPD, symmetric positive definite. So we basically do the determinant and we find out whether it's positive or negative. If it's positive, we're good when we go on, as we did for in this very case. So basically, we used the fact that L and transpose is equal A, and we found the lower triangular matrix and its transpose, which are those. And then we said, hey, if A x equal to C, so our initial system of linear equation, okay, then and L transpose is equal to A, then L transpose X is equal to C. And we use these facts to basically say, okay, I'm gonna use the lower triangular matrix, and I'm gonna find a new vector y with a component I, j, and k. We basically set it equal to c, which was this guy here of the original system of linear equation. And we basically found out found our component I, j, and k of the vector y. Then we use the lower triangular matrix transpose, so the one that we have here, and we said, okay, we're going to find now x, the vector x given with by the component x, y, and z, and the way we're basically gonna find it is going to be by setting it equal to the vector, the component of the vector y that we have just found. So we did it, we solved the system linear equation, and we found our solution. And then last but not least, we verified that our solution were correct by plugging in those three values into the original equation of the linear system equation. And we basically got 2 equal to 2, 0 equal to 0, 0 equals to 0. Therefore, everything was verified. So the key idea here is that by doing those kind of operations, the linear system of equation you have to solve are going to be easier than the original linear system of equation that we have. It may not seem so by the calculation I've done for these particular matrices, but believe me, it is. So once again, I hope it helps. I'm gonna post probably another video about this method. Probably I will, maybe not, but I think I will. I'll try my best to do it. All right, I hope it helps. Once again, bye.